In the last episode, we looked at bias, how algorithms can absorb inequality from the data we feed them. But identifying bias is only half the work. The real challenge is testing whether a model is not just accurate, but equitable. Today, on Curious Modeling, we're exploring how data scientists, ethicists, and law enforcement agencies test fairness in predictive policing models. Because in analytics, validation isn't just about performance, it's about justice. In modeling, validation is the process of asking, does this model actually work? And for whom? There are two big kinds of validation. Statistical validation, which is how well does the model predict what it claims to predict. And ethical validation, does it do so fairly across groups and contexts? In predictive policing, both matter. Because a model that's 90% accurate but 90% unfair isn't useful. It's dangerous. Let's start with the basics. To test accuracy, analysts use standard metrics like precision, recall, and AUC, or area under the ROC curve. Precision asks, of all the times the model predicted crime, how often was it right? Recall asks, of all the crimes that actually happened, how many did we predict? AUC summarizes how well the model distinguishes between crime and no crime. These metrics tell us how the model performs, but not for whom. And that's where fairness testing comes in. Fairness testing asks a deeper question. Does this model perform equally well for different groups of people or places? There are several ways to measure that, but three are especially important. Demographic parity. Do groups receive the same proportion of positive predictions? Equalized odds. Are error rates, false positives and false negatives, balanced across groups? Predictive equality. Do false positives, wrong high-risk flags, happen at similar rates? Each metric reveals something different, and none alone tells the full story. Fairness isn't a single number. It's a pattern of performance that reflects systemic equity. Of all the fairness issues in predictive policing, false positives, labeling someone or someplace as high risk when they're not, may be the most damaging. Because false positives don't just hurt the model's accuracy. They affect real lives. They can lead to over-policing, loss of trust, and reputational harm. That's why fairness testing focuses heavily on error balance. If one community experiences more false positives than another, the model's outputs are amplifying inequality. Accuracy without accountability isn't progress. Fairness isn't only about people, it's also about places. Spatial validation tests whether a model performs equally well across different neighborhoods. Temporal validation checks whether predictions stay stable over time, or if accuracy collapses as social patterns change. A truly fair model isn't just consistent across demographics, it's consistent across geography and history. Testing fairness isn't just about metrics, it's about process. Responsible data teams use validation dashboards, open reports that document each stage. What data was used, how it was cleaned and weighted, which fairness tests were applied, what limitations were found. Some cities even publish algorithmic impact assessments so the public can see how models were tested before deployment. Transparency turns validation from a technical exercise into a civic one. Validation isn't a one-time audit. Models learn from new data. And that means bias can reappear over time. Continuous evaluation, retraining, re-auditing, and public reporting keeps predictive systems accountable as conditions change. Because justice isn't static, and neither is data. Fairness in predictive modeling isn't about perfection. It's about vigilance. Every model reflects choices, what to measure, how to weigh it, and who defines success. By validating not just accuracy, but equity, we start to turn predictive policing from a closed system into a transparent one. Because in the end, a just model isn't one that predicts perfectly. It's one that learns responsibly. In our next episode, we'll explore that idea in practice. Predictive prevention. How data can be used not to police, but to protect.